Draw the Newman projection of the most stable and least stable conformers of 3-ethyl 2-methylhexane viewed through the C2C3 bond. So the first thing that we need to do is we need to draw our molecule. We have a hexane, so we can draw a 6-carbon zigzag and number it 1, 2, 3, 4, 5, 6. 3-ethyl means that there is 2 carbons attached to carbon number 3, 2-carbon chain, ethyl. And 2-methyl means there is 1 carbon attached to carbon 2. Now we're supposed to look at carbon 2 and then at carbon 3. Let's first write out all of the groups that are attached to carbon number 2 except for carbon number 3. So we will look at 3 groups that are attached to carbon number 2 other than carbon number 3 because it's behind it. For carbon number 2, we can see that there are only 3 bonds shown, and we know that every neutral carbon wants to have 4 bonds, which means that it has 1 hydrogen attached to it, which was not shown, and I'm going to show it to make it clear. So what groups is carbon number 2 attached to? Carbon number 2 is attached to a hydrogen. It's also attached to 1 carbon here, which is a methyl group. I can write CH3. And it's also attached to 1 carbon here, which is a methyl group again, CH3. Now let's go ahead and look at carbon 3. What 3 groups is carbon 3 attached to? And again, we do not take into account carbon 2. So whoever is the bond is your partner in the bond you're looking at, you do not look at that carbon when listing the groups it's attached to. Carbon 3 here has 3 bonds, which means that a hydrogen is not shown, so we will show it in order to give it 4 bonds. So what groups is carbon 3 attached to? We can even highlight it. First of all, we have a hydrogen. We also have an ethyl group, which is CH2, CH3, or we can just draw it out in the Newman projection, which is probably what I will do. And then we also have a propyl group, which is CH2, CH2, CH3. So these are my 3 attachments. This. So carbon 3 here is attached to a hydrogen, ethyl, and propyl. I can write CH2, CH2, CH3. Now that I have listed the 3 groups that each carbon is attached to, I am going to draw the most stable and least stable conformers. The most stable conformer is where the front carbon and the back carbon are rotated in such a way where the groups attached to 2 carbons are as far away from each other as possible. They do not bump into each other, and that's what makes it more stable. And this conformation is called staggered. There is another conformation where we can rotate around the bond and the groups on the 2 carbons will be right next to each other, right underneath each other. And this conformation is called eclipsed, and this conformation is least stable. Let's start with our most stable conformation. So we will draw our staggered conformation. The carbon in the front is carbon 2. I can put a little 2 here to signify that's the carbon. And it is attached to a hydrogen, a methyl, and another methyl. The carbon behind it is attached to these 2 groups. For the most stable conformation, we want our biggest groups to be as far from each other as possible. So my biggest group is propyl, CH2, CH2, CH3, and it wants to be as far apart, as far away from one of these methyl groups as possible. So we can, for example, put it here. CH2, CH2, CH3. It is still close to the other methyl group, but I have no choice. The worst would be here because then it would be in between these 2 methyl groups. So that would not make it happy. Next, my other biggest group is ethyl, and again I wanted to put as far away from the other group, so I can do CH2, CH3, that's my ethyl group, and then this would be hydrogen, and so this would be the most stable conformation. Now let's draw the least stable conformation. I can leave my front carbon the same, CH3, H, and CH3. And for the least stable conformation, it will be eclipsed, which means the groups will be right behind each other. And to make it less stable, I will put my biggest groups right next to each other. So this is a methyl group, and I'm going to put the propyl group right next to it, CH2, CH2, CH3. This is a methyl group, and I'm going to put my ethyl group right next to it, CH2, CH3. And this is a hydrogen, and the only group that I have left is a hydrogen. This is the most stable conformation, and this is the least stable conformation. We can say most stable here. Another way to draw it is you could just draw lines. You don't have to write it out. Or you could write methyl, ethyl. You could write the words out also to show the groups.